Welcome to the sLORETA Basics tutorial. Here you will learn step by step how to operate the program. sLORETA uses EEG measurements at the scalp to estimate the location of neuronal generators in the brain. The 3D distribution of electrically active tissue in the cortex can be visualized and quantified in sLORETA. Note that sLORETA is only one method out of many that is available for source localization. Once you have the program open, click on Main Utilities. I have one open, and I'll bring it up. You'll notice a series of tabs at the top of this window, and you'll want to work through these tabs sequentially. The first three tabs help you to create the coordinate file, and a coordinate file is the spatial location of each electrode that's sitting on the scalp. Now, we already have electrode coordinate files built for each net that we use in the lab. So the biosemi, the hydrocell, and the old GSN nets. And you can find these coordinate files in the Buchanal Dropbox. So let's skip over to the electrode viewer. Here, you can double check the position of each electrode. I have the hydrocell coordinate file on my desktop, and I'm going to drag it into this field. Now I can scroll through each electrode to make sure that it's in the right location. To do that, you'll want to compare what you see in the electrode viewer to an electrode map. And you can find maps like this in the lab, or in this case, on the EGI website. Once you're sure that all your electrodes are in the right location, go ahead and click on Electrode Coordinates to Transformation Matrix. To perform its algorithms, sLORETA uses a model of the cortex that's divided into over 6,000 tiny sections, and each one of those sections is only 5 cubic millimeters in size, and each one of those cubes is called a voxel. So, for this step, the transformation matrix is used in the conversion of scalp data to voxel space data. So let's make a transformation matrix using the coordinate file. Use the File Explorer over here on your left to navigate to your study folder. In this case, my study is called Emotion 2012 P100. So I'll find the folder I've created with the coordinate file in it, and I'll drag it over here to where it says File with Electrode Coordinates. And once you drop it in, you'll see that it's generated an output file with the extension .spinv. That's the transformation matrix. Over here, you'll be able to choose your level of regularization. So go ahead and click Automatic, and then click Go. This will create 4 different transformation matrices, each with a different level of regularization, with the values 1, 10, 100, and 1000. Now, I've already created these files and moved them into a folder called Transformation Matrices under Automatics. And here you can see them all with their corresponding values, 1, 10, 100, and 1000. So, now we have everything we need to actually localize scalp data. So go ahead and click on ERPs to sLORETA. In this screen, we're going to drag all of our single subject ERP files into this main field. Make sure to change the file mask to reflect the file extension on your ERPs. For this sample experiment, we're going to assume that in condition 1, participants viewed a happy face, and in condition 2, participants viewed a neutral face. So let's get all the ERP files from condition 1 and drag them into the main field. Now we have to provide a transformation matrix. So let's move over to the proper folder under Automatics, and let's use the transformation matrix with a regularization constant of 1. You'll want to repeat this step for each SPINV file. This way, you'll be able to see how each regularization constant changes the solution space. Now click Go. Once that's finished, go ahead and take a look in your ERP folder. There you'll see a new file has been created for each subject with the extension .slore. In the next step, we're going to load these files up and we'll finally be able to see images of brain activity. And a small organizational tip, you'll want to take each of these sLORE files and move them into a folder that will help you keep track of all the different regularization constants that you've used. So in this case, I would move all of those .sLORE files into automatics and signal to noise ratio 1. Okay, so I'm back here on the main sLORETA window. Go ahead and click Viewer Explorer. This is where we'll be able to see images of brain activation. I've already got one of these windows open, and I'll bring it up. Okay, so you'll see 3 main windows, and you can arrange them any way you like. We've got the Cortex window, our signal window, and all of our slices. Okay, so let's load up an sLORE file. So bring up the File Explorer here, and you want to navigate to your study folder. So emotion, localized activity, condition 1, automatics, signal to noise ratio 1, and here you'll see all the sLORE files for each subject. So let's double click on subject 1. Okay, so now we can see localized brain activity, and we can see the largest spike in global field power occurs at the time of the P100. And sure enough, we see activation in the occipital region. Now you'll want to, of course, look at all your conditions and all your subjects and all your regularization constants. Okay, so just have fun exploring your data. Now in the next step, I'll show you how to extract regions of interest from these sLORE files. This way, you can compare and run statistics on areas of the brain that you're particularly interested in. Okay, so a region of interest is a user-defined group of voxels that usually corresponds to a Brodmann area. Go ahead and click Main Utilities. I've got a window open, and I'll bring it up. There are 3 methods for creating regions of interest in sLORETA. ROI Maker 1 allows you to input coordinates that are used as seed points, and with these seed points, sLORETA will gather up all the nearest voxels and call that a region of interest. ROI Maker 2 allows you to input specific Brodmann areas. But if you wanted to split a Brodmann area up into, say, medial and lateral sections, you would not have the control to do this using this method. However, ROI Maker 3 gives you complete control over every single voxel in sLORETA. That makes ROI Maker 3 the preferred method. So here's how you define your ROIs. Click Export a blank ROI definitions file. When you do, you'll get an Excel file that looks like this. Here you can control exactly which voxels make up your ROIs. You can see the total number of voxels you have to choose from, the total number of ROIs that have been defined. Now, keep in mind, if this is your first time working with the file, this number will be 0. You can see the X, Y, Z coordinates for each voxel, the lobe, the anatomical structure, and the Brodmann area. So, for example, if you wanted this voxel and this voxel of Brodmann area 20 to make up your first ROI, simply input 1 and 1. And if you wanted this voxel and this voxel of Brodmann area 20 to make up your second ROI, simply input 2 and 2. Then just save the file and go back to the main utilities window. Now take your ROI definitions file and drag it into the first field. Then take your transformation matrix and drag it into the second field. Once you click Go, you'll get this output file, which can be loaded into the viewer to produce images of your ROIs. So let's open up the viewer window now and take a look. So let's open up the file that we just created. Go to File Explorer, double click the file. Okay, here we go. So once the file's loaded, you can scroll through each ROI with these arrows here at the top. Now I've defined 27 different ROIs, so let's take a look at a couple of them. So the first ROI is BA10 medial left, then we have BA10 medial right, BA10 lateral left, and BA10 lateral right. So the idea here really is to examine your ROIs, and if there's one too many voxels or not enough voxels in your ROI, then you'll have to go back to the Excel file and make the necessary adjustments. The next step in sLORETA is to take the files that have the localized activity in them and extract from them only the activity that falls within our ROIs. So let's do that now. Let's go back to the main utility window and click on sLORETA to ROIs. Okay, so to perform the extraction, just drag your ROI definitions file into the second field and your .slor files into the first field. Once you hit Go, a new text file will be created for each person. I've already created these files and moved them into a folder called sLOR to ROIs. I've got one open here so we can see what it's all about. These text files hold the average activation for each ROI for each time frame in the epoch. There's one column for each ROI. We have 27 ROIs defined, so there's 27 columns. And we have one row for each time frame in the epoch. Since our epoch has 256 time frames, we have 256 rows. You're now ready to import this text file into SPSS and run statistics on your localized activity. Thank you for watching the sLORETA Basics tutorial. The next tutorial will deal with cross-spectral analysis and connectivity.